don't get scared when you see an HL question like the one above me. On this video, I'll teach you how to differentiate between SN1 and SN2, and also how to decide what the rate expression for each reaction is going to be. Stay with me until the end of this video. Let's go. 2-bromo, 2-methylbutane. So this molecule right here, the bromine is in carbon number 2 and also is a methyl radical, reacts with a warm solution of sodium hydroxide to form an alcohol. So what's going on here? This molecule, this halogenoalkane, that's the name of the function, a halogenoalkane, is going to undergo a nucleophilic substitution. How do I know that? Because NaOH will release OH minus ions, which are very strong nucleophiles. And then in the end, I'll have an alcohol and a salt with the same halogen that came from the carbon chain. Now we just need to decide if it's SN1 or SN2 and deduce the rate expression.
How do we do that?
First, you have to ask yourself, is my halogenoalkane primary, secondary, or tertiary? In order to figure that out, look at the carbon which is bonded to the halogen. And then you ask yourself, how many other carbons is it bonded with?
Then we count.
The carbon that is bonded to the halogen is bonded to 1, 2, 3. The carbon that is bonded to the halogen is bonded to 3 other carbon. That makes my halogenoalkane, my CX,
Tertiary. Write this down.
Every single time that I have a nucleophilic substitution and you have a tertiary halogenoalkane, you're gonna go through mechanism SN1. More on that later. I will explain the whole mechanism in another video. SN1, because it's unimolecular, so we can already eliminate A and D. So it's gonna be SN1. And what does the name unimolecular entail? It entails that the rate only depends on one molecule.
Which molecule?
The concentration of my halogenoalkane.
It does not
Depend, like SN2 depends, on the concentration of my nucleophile. To solve a question like that, first you have to figure out if the carbon that contains your nucleophile is primary, secondary, or tertiary. If it's tertiary, it's always going to follow SN1. It's called the unimolecular. That means that the rate only depends on the concentration of your halogenoalkane. In SN2, bimolecular, it will depend both on the concentration of your halogenoalkane and of the solution that will produce your nucleophile, in this case NaOH. Since it is unimolecular, the answer will be B, because the rate expression only contains K and the concentration of your
halogenoalkane.
This expression in C would be the correct answer if it was an SN2 mechanism. So the answer for this question is alternative B. All right, everybody, for more questions like this, follow my social media accounts, Mr. Diego Tutoring on TikTok and Instagram. Please also follow my YouTube channel at Crushing Chemistry. Have a wonderful rest of your week, and I'll see you later. Bye-bye.